Multiplying whole numbers. Example 1. There's 4 groups of 5 kids. How many total kids are there? So let's visually think about this first before we look at the numbers. So we have 4 groups. And then there's 5 kids in each one. So if we were to count this all up, right, we would get 20. So each kid, right, in the 4 groups, if they're all accounted for, that's 20. And so 4, right, times 5 is equal to 20. So we can visually kind of think about them. Maybe we just know what that is. 4 times 5 is being 20. As we remember our multiplication tables, and if not, maybe we just need to brush up on that. And so another way, so I'm going to also show you this, is that what if we also broke it down into, so rather than say 4 groups, say there was 5 times 2, right? So there's 5 kids in 2 groups. Well, that's 10, but that's only counting for 2 of the groups. So we'd have to do that again, right? And that would equal 10. And then we add those together to get 20. So notice how we can kind of start breaking things down to maybe things that are a little bit easier. Maybe we forget what 4 times 5 is, right? We forget that that's 20. But maybe we know that 5 times 2, because if we have 2 nickels, that's 10 cents, right? And so if we did that twice, we would get to 20. So there's just multiple ways we can kind of start working with numbers and moving things around, because numbers are really flexible and we can try to make it work to figure out how we can get to the answer. So maybe it's not always the same way as someone else would do it, but that's okay. There's multiple ways to always get to an answer. So let's look at another example. So example 2. But before that, let's go over multiplication and showing different ways. So say we have 2 times 3. Well, having parentheses for each number next to each other represents multiplication. Maybe we can also represent multiplication like this with a dot. That means 2 times 3. Or there's this way, which we've probably seen before, which is the x, where it's 2 times 3. So there's multiple ways to use multiplication. We might use this, especially when we get into variables, when there's variables in our problems where like maybe x, y, and z could be in there, so we want to avoid using x as a times. Or we could use it like this. So now let's look at the second example. So a preschool costs $625 a month. A pair of parents want to pay for 6 months in advance. How much do they owe for those 6 months with $625 per month rate? So let's go ahead and multiply these two. So we're going to set this up. So when we set it up, we put the larger number on the top, the smaller number on the bottom. Then we're going to line up the place values, right? Where the 5 and the 6 are lined up with each other because they're both in the 1 spot. And now we can go ahead and start to multiply. So we're going to start with the 5, right? The 5 and the 6. So we go 6 times 5. So that's 30. With the 0 below, we're going to carry the 3. Then we're going to go 6 times 2, which is 12, and then we add 3. So whatever gets carried over, we add that. So it's 6, right? I'll put this out. 6 times 2 plus 3. So 6 times 2 is 12, plus 3 is 15. So we put the 5 below, carry the 1. Now 6 times 6 is, right, 36, and then we add 1. So that would be 37. So we'll just put the 37 below. We'll add the dollar sign, and that's how much the parents would owe. Now let's look at another example. So example 3. There are 18 kids in the class, and each needs 7 pieces of paper for the project. How many pieces of paper do you need? So this is for the teacher to figure out how many pieces of paper they would need. So we're going to go ahead and put the 18 on top because it's a larger number, the 7 below, and we go ahead and multiply. So we can go 8 times 7, so that's going to be 56. You're going to put a 6 below, carry the 5. Now 7 times 1 is 7, plus 5 is 12. So that's how many pieces of paper the teacher would need. Now I'm going to show you a quick trick. So this is kind of what people do in their heads, is they actually will round maybe say 18 to 20, and then they go ahead and times it by 7. So the cool thing about multiplying anything by, say, like tens, right? Like it's 10, 20, 30, 40, etc. What we can do is just look at 7 times this 2, so that's 14. And then we're going to go ahead and add that 0, right? To indicate that it's 140, because we're not multiplying 7 times 2, it's 7 times 20. So we can count for that by just adding the 0. And then, because it's 18 times 7 and not 20 times 7, we need to go ahead and go 2 times 7, right? Because 20 minus 18 is 2. So 2 times 7 is then 14. Then what we do is we take this number and subtract this number from it. So we got 140 minus 14. So if we go ahead and borrow, 10 minus 4 is 6, 3 minus 1 is 2, and then we bring down the 1. And we get 126. So we can see that I checked out because that's what we got here. So you can see that this trick of rounding 18 to 20 and then just subtracting the 2 times 7 would have got us to the same answer. And so sometimes we're able to do these things in our heads, especially when we work with numbers a little bit more. We can kind of start to see this rather than having to go ahead and multiplying this out. This can sometimes be easier just to do in our heads.